Okay, so when we balance equations, I need to give you some background first to help you understand why we have to do it. So if we go with a pretty standard synthesis reaction, just to say sodium plus chlorine, so chlorine gas, will give you sodium chloride. So we've used this reaction already. It's a synthesis reaction. If I come down here, though, and I start to draw the particles, if this is sodium, and this is the molecule chlorine, which is diatomic, and that gives me sodium chloride, you can see that, if I look at my particulate diagram here, that I actually end up being short on the chlorines. On this side, I have 2 chlorines, so we can actually take an inventory, right? On this side, I have 1 sodium, and I have 2 chlorines. On this side, I have 1 sodium and 1 chlorine. Have I done anything that has confused you or you don't understand? So, there is something called the law of conservation of matter, and it says that matter cannot be created or destroyed. But it would seem to me like this chlorine has been destroyed from the left to the right, from the reactants to the products. So, that's not okay. So what we have to do is we have to balance. Now, it's very tempting to just be like, oh, I know, I'll just put a 2 right here. Can you do that? Now, the charge for sodium is 1 plus, the charge for chlorine is 1 minus, or chloride is 1 minus. So to have your charges be neutral overall for the ionic compound, it needs to be 1 of each. So you cannot do this. When we balance equations, the reason that we have been naming and very, very, very carefully checking each and every compound is so that everything's neutral and it's what it's supposed to be. So once you do that, like we've been doing for 4 weeks, you cannot come in and start changing it. So the only thing that you can do is you can add what's called coefficients. So, what I could do here, do you see how I'm a little bit short on chlorine on the right-hand side, on the product side? Well, if I need another chlorine, right? So I can actually add another sodium chloride. And then like we did in the activity yesterday, that is to say that I have 2 sodium chlorides. And so now I have 2 sodiums and 2 chlorides. But on the reactant side, is it balanced? So have the same atoms present. No, what's short? Sodium. So I need another sodium. So now this, I'm going to scoot the chlorine over. Scoot, scoot, scoot. Now I have 2 sodium atoms, 2 chlorine atoms, 2 sodium atoms, 2 chlorine atoms. This is balanced. So what I have done, let's change that. What I have done is I've added these numbers in front. That is the only thing you can do to balance equations. You cannot change formulas, you can't do anything. The only thing you do is add coefficients, and these are called coefficients. So the numbers out front are called coefficients, and that's what we use to balance. The little numbers, just as a reminder, are called subscripts. We've been using subscripts. We have not used coefficients yet. So far, so good? Makes sense. Okay, so just to keep going here, the reason we have to balance is because the law of conservation of matter, which you probably already learned, and basically matter cannot be created or destroyed. I already told you this, but now we're writing it down. And you saw in the example that I just did how a chlorine atom would have been, quote, destroyed if I had not balanced the equation. So we can balance equations to obey this law by adding coefficients. We cannot change subscripts. idea. So I'm going to work a few examples for you. You'll probably find that it's not a big deal. But because you're in honors, I am going to do some trickier ones with you, which will be fun, maybe, maybe not. Okay, so let's do another synthesis problem. For example, do you guys, I see a couple people right now. Wait. Okay, so our next example will be hydrogen gas plus oxygen gas will give us water. I'm not going to draw the particulates, the little circles. I'm not going to do that every time. But what I am going to do every time is I'm going to make an inventory of atoms, or elements, I should say. And I'm going to do that right below the yield sign. So once I do that, I'm going to see how many hydrogens I have. On the reactant side, I have 2 hydrogens and 2 oxygens. Have I lost anybody on that? Pretty straightforward. On the product side, I have 2 hydrogens and I only have 1 oxygen. This 2 only applies to the hydrogen. If I do, like, it's tempting to be like, oh, if I just add this, it'll be balanced, yay! But no, that's the difference between water and hydrogen peroxide. Have you heard that joke where it's like, 2 men walk into a bar. One orders H2O and the other one orders H2O2. That man dies. Have you heard that? Hydrogen peroxide is H2O2. And it is it's basically the stuff in the brown bottles that you can pour in your boo-boos. It's a rapid oxidizer, so it'll eat your insides if you drink it. Okie doke. So what I'm going to do when I balance is I'm going to start at the top of the list, and I'm going to work my way all the way down. This is not much of a list, so you'll see what I'm talking about in a minute. But you start at the top of the list, and you work all the way down. Don't try to, like, deal with stuff until you basically go all the way down and then come back up. So that doesn't really apply, but I'm going to go ahead and keep saying it. Hydrogen is good, oxygen is not. So what can I do to this water to get more oxygen? What should I do? So I'm going to add a 2 here. So that's going to give me 2 oxygens, and now that will give me 4 hydrogens. Go up to the top of my list. Now my hydrogens on the reactant side are a little bit short. So what can I do to get 4 hydrogens up here? Oops. So now my reaction is balanced. In front of the oxygen, there's an understood 1. You can write the 1 if it makes you feel happy inside. You technically should not do that, though. On your quiz on Friday, it's multiple choice, and it will say you have to balance the equations, and then it will say the coefficients of the balanced equation would be 2, 1, 2. Okay. Yes, ma'am.
So since it's H2 plus O2, what would you add to get hydroxide?
So you wouldn't be adding anything. Then you would be given like hydrogen and oxygen gas synthesized to form water. You can't, you know what I'm saying? Like we're not making but what was told to us. So you wouldn't create anything other than what was supposed to be made. So that's what I'm saying. Like if you did this, what I'm saying is now I don't have water, now I have a different substance, so I can't do that. That's what I was trying to say.
Also, in real life, how would you make
okay, peroxide is a polyatomic ion. It's O2 minus 2. So it bonds with hydrogen to get H2. So this is peroxide. This is hydrogen. That's hydrogen peroxide. But I went ahead and gave you the formula. Okay, so what we're going to do is, so you don't have to write so much, my examples for you are, we're going to use this for like our notes, okay? If you get it, so you want to work ahead, number 6 is really tricky. So maybe don't be upset if you can't do number 6. But please, I would encourage you to listen to me until you really, really get it. So number 1 is I have sodium sulfate. Now this practice sheet or this note sheet is really nice because it already has everything neutral. But like, let's say that you write sodium sulfate and you forget to make this 2 right here. Everything you're about to do is going to be wrong, which is what I've been trying to tell you. But I just want to reiterate that. So sodium sulfate plus carbon gives me, or yields, Na2S and carbon dioxide. So notice there's an inventory. The inventory can go below the yield sign. And I'm just going to count them up. Go ahead and count them up on your paper. You can do the inventory. Inventory is where you count them. Just like inventory at the store. me, notice that sulfate has broken up. Like here we're counting individual atoms. So in this situation, the polyatomic ion isn't one thing anymore, right? We're counting the atoms that are in there, the little circles that we'd have to draw like we did yesterday. So, Maria, can you tell me the inventory that you got? What did you get for sodium?
2.
And then on this side?
2.
And then sulfur?
1.
And then
1.
oxygen?
4.
Okay.
2.
Okay.
1.
All right, so start at the top of the list, work your way down. If you change something towards the top, don't go back to it until you work all the way to the bottom. If you'll do that, you can't screw this up, like I'm sure. All right, so sodium's good, sulfur not so much. Oxygen, see how I need 2 more oxygens? I have 2 present. 2 times 2 is 4. But then that also changes the carbon. Work down the list. I already did sodium, sulfur, and oxygen. Now I'm to carbon. Notice here I have 2 carbons. On this side I have 1. So what can I put right here? And it's balanced. So on the quiz, if you were asked the coefficients, it would be 1, 2, 1, 2. But you should not write the 1 down. If you do, I'm not going to count off, but it's multiple choice. Robin, do you have a question? No? Okay, cool. Moving on to number 2. I'm going to do number 2, and I'll let you try number 3. Whee! All right, so I have phosphorus trichloride plus water. Go ahead and do the inventory on your own. So, Brooklyn, what did you get for the phosphorus?
1.
And then 1 over here as well. Chlorine?
3.
Hydrogen?
2.
Good. Do you see how you have to add the 3 and the 1 to make 4? All right. And then oxygen? 1 and 4?
Yeah.
Okay. Now, notice from the do now that this is phosphoric acid because it's phosphate. Ate and acid said ick, right? All right, so now let's go ahead. Do you want to try to balance it on your own?
Wait a second.
Here's 3.
Oh, just kidding. So that's the importance of not messing up your polyatomic ions. Do you see how like all my work was about to be wrong just because I wrote down the wrong polyatomic ion? So I'm glad you said something. Who said that to me? You? Here, come get a ticket. Thank you. Do you want to try to balance it, see how it works? I'm going to work it out. Go ahead and give it a try. Work down the list and then go back up to the top. Thanks, Brooklyn. Oh, I misheard you right. I'll give you a minute or 2. Oh yeah, it sure is. I see people are working, but they're like working on the back, so. This big area over here is for you to write this in. Hey, the big area underneath the reactants and the products is big so you can write the numbers and cross them out there. See a couple people still working. If you feel like it, you can go ahead and try 3. You feel like it. I probably should say that. If you're ready, you can go ahead and try number 3. I don't know that anybody just feels like it, right? Hopefully you do. Okay, so let's go ahead and take a peek at this one. Phosphorus is great. Chlorine, not so much. So I have 3 on the reactant side, but only 1 on the product side. So somebody was asking me earlier, well, how did you know like where to change it? At every intersection of my decisions, there's only one option. There's never more than one thing that you can do. I mean, as far as what we'll do in here. So I need 3 chlorines. The only thing I can do is put a 3 right here. That also changes the hydrogen to 3 plus 3 is 6. See what I did there? Okay. So I did phosphorus, I did chlorine, hydrogen now. When I look at the hydrogen, I have 2 and then I have 6. So if I need 6, the only option I have is to put a 3 here. That will give me 6, and then I have 3 oxygens. And usually, by the time you get to the bottom of the list, it'll work itself out. Sometimes you'll have to start back at the top though. Do you want to try number 3? Go ahead. If you can do number 6 by yourself and get it right, I'll give you 4 tickets. But don't just skip straight there. It's kind of a crapshoot if I get number 6 right myself, to be honest. Like, I'll get it right. I'll get it right, but like, I'm not overshooting and have to reduce, which, don't worry about it. 6 is not going to be a big deal. Oh, Christian, do you already have 6 done? Okay, I'll come over there in a second. Yeah, so like, yeah, these are 6 because there were 2 to start with. Okay, so does anybody need another second to work on this? All good? All right, well, let's check our answers if you already did it. So the lead and the oxygen are looking pretty good. The nitrogen, I need more nitrogen. What can I put right here? Everybody? 2. And so that will give me 2 nitrogens and then 6 hydrogens. So the next one, the hydrogens, I have 2 and 6. So for this one, I'm going to have to put a 3 right here. That changes this to a 6. But then it's going to change the oxygen to 3. So I'll go all the way to the top, again, because I worked to the bottom. I'll go to the top. Lead's still good. Oxygen is not. I'll have to put a 3 here. So that will give me 3 and 3. Everything else, let's go down to the bottom. Back up to the top, the lead. I need 3 of them. I'll put a 3 here. Feeling okay about that? I do want to show you something. I'm going to let you work through the rest, and then I'll work them out on the board, just so you can feel good about what you're doing. So let's say we, like at the beginning of class for the do now, I had calcium hydroxide. So if I do an inventory of this, I have 1 calcium. How many oxygens do I have? And then how many hydroxides do I have? I mean, hydrogens do I have? 2. Okay. I have 2 hydroxides. So this is the importance of those parentheses. This is why it matters. If you don't have a parentheses, you have 2 hydrogens, only 1 oxygen. And you only have 1 calcium because it's not in the parentheses. It's just like math class. Now, what if I do this? How many calciums do I have? How many oxygens do I have? 8. How many hydrogens do I have? Because it's 2 times 4. Okay? So do the next one, but be aware of that. Yes, sir. Oh, sure. Oh, that's not right. I don't think they were that high, to be honest. So start at the top. Start at the top. can't mess up. Yes, ma'am. You don't get it. Oh, I asked you a second ago. Oh, wait, how to do that or the whole thing? How to count that? How many copies? Oh, just kidding. Oh, okay. This is fine. Yeah. Okay, you get that. So start at the top. What can you do to fix it? And how would you do that? You can only, the only option you have is to change coefficient. So what is that coefficient? Put it there. Okay, now change that to a 3. That's what it is. Now, when you put a 3 there, what happens to your option right here? You had 2, but now you have a 3 in front of it. So what do you got now? You hold 6. Yeah, so write 6 down. Now, how many hydrogens do you have here? Also, there was 2 times 3 is plus 3 more from this one is 7. Now, keep going. Right? Is it 6 and then 3 more? So nitrogen, see I need another nitrogen over here. So what it has to go right there. Right. Now see how your hydrogen is changed? Now 6 and then you have 6 over here, right? So what how many hydrogens do you have now? Write that down. Nope, you only did it to this side. You have on this side you have 6 and 6 is 12. Did you get what I'm saying? 2 times 3 is 3 times 2 is. So I have 12. Okay. So write down 12. Now we're just moving our ways down the list. So this is good, this is good. Now we're at hydrogen. I have 2. What can I put here to get 12? So I have 12. That would be equal. Not 12 because you have 2. So what? Yeah, write down 6. Okay. And that also changed your oxygen to. Write down. Now, are all your numbers right? Straight down the page, are they all the same? So you had 12, you never changed it. So you're done. That's all I'm doing. And that one's pretty hard. So let's take it one element at a time. You want me to check yours?
Yeah.
And yours.
Minus 2.
Yeah, well, before done. Okay, so let me work this one out now.
Which one?
I'm gonna work out 4, and I'll go ahead and work out 5. Have y'all done 5 yet? Okay, I'll give you a minute. Do 4 and 5. I'll give you time, and then I'll work them out. If you need help, call me over. As far as checking it, I'll write the answers on the board here in a minute. Do you have the bonus then? Or bonus, but do you have the number 610?
I have a question.
Yeah.
I don't know what happened here, but I can't use the number.
No, you're right. Look, this is 2 times 3 is 6. 2 times 3 is 6. That's 12. These are right. You just didn't add them up right. 6. 6 is 12. There are 2 hydrogens. Okay. Yes. That's right. Good. What you got? Yeah, I'm pretty sure. Yeah. Number 5 is actually really quick to solve. When I was a kid, I hated it when the teacher did all the easy ones, and then like I had hard ones for homework, but that's how it always is, right? So like this note sheet has hard ones. When you go to do your practice, you'll be like, oh, this is a joke, okay? So don't freak out when it's easy, because some of them are easy, and I think the ones in the quiz are easy. So, yeah. number 4. If you were done, please check your answers. So I got 3, 2, 2, 1. That's pretty straightforward. 1, and this is 1. And then hydrogen is 2 plus 3, which is 5. Then oxygen is just 2. Okay, so start at the bottom. Sorry, Drake. Start at the top. And so magnesium, I need 3 of those. So that will now change my oxygen to 6, and will change my hydrogen to 6 plus 3, which is 9. And then I'm going to keep working down my list. Magnesium I did. Nitrogen's next. Notice how I didn't come down here and start messing around. I'm going down the list. So nitrogen, I see I have 2 on the left, or on the reactants, and then only 1 over here, so I'm going to put a 2. That changes this to 2, and now I have 6 hydrogens here and 6 hydrogen here, which gives me 12. So now I'm to hydrogen. Hydrogen has 2 on this side versus 12, so we'll put a 6 here. That will give me 12. And then I have 6 oxygens, and I'm done. Okay? So if you needed a second to finish up number 5, take it. So check your numbers 5. So here's my inventory. As far as the hydrogen goes, I have 2, and then I have 2 more, which is 4 on this side, and the oxygen I have 2. So good, good. Hydrogen, you can see that I need more hydrogen on this side. That will give me 4 of those, and that will give me 2 of those. And sometimes they're that easy. And sometimes when you're doing practice here in a minute, they're already balanced. So to save yourself some time, you can quickly check if there's 1 of each of everything, then you don't need to do this, okay? So some of them are already balanced. That happens occasionally. Number 6 I'm not going to do. It's not worth it. It'll just make your head go crazy. And then 7 and 8. So take a minute or 2 to do 7 or 8. I can do number 6 if you really want me to. Yes, ma'am. Okay, so last call for number 6, and then I'll do number 6. Oh, you got it? 1 second. That's fine. You did it? Cool. That's right. You got it? Anybody else? Did it? Look. So either look at number 6 or go ahead and finish 7 and 8, your choice. So, sorry, flu shot calls. I'll tell you why I have to go get that in a second. So HCl and O, and you can see I have 1, 1, and 2, and over here I have 2, 1, and 2. So the hydrogen chloride or hydrochloric acid needs a 2 there and a 2 there. And now my oxygen is a little bit off. This one actually you have to go back up to the top. So this one, notice the only thing I can do to get more oxygen is put a 2 here. So that changes this to a 2, and now hydrogen changes to a 4. So I finish out the list. I go back up to the top. Hydrogen. So sometimes you do have to erase the coefficients. I will have to have 4, and the way I'm going to get 4 is by putting a 4 here. There's no other way to do it. That will also give me 4 chlorines. And then the chlorine here has to be a 2 to give me 4. But that was kind of hard. Did you okay? Okay, great. And then on number 8, I have phosphorus trichloride plus water gives me phosphorus acid, like on the warm-up. So be careful. So when I go to add, do my inventory, I have 1 phosphorus, I have 1 phosphorus, 3 chlorines, 2 hydrogens, 1 oxygen. On this side, I have 1 phosphorus, 1 chlorine, 4 hydrogens, and 3 oxygens. So starting at the top, phosphorus is good, chlorine is not so much. I'll put a 3 here. That changes this to 3. That changes this to 3 plus 3, which is 6. On the oxygens, you can see how I'm short, so I'll put a 3 here to get 3 oxygens. That changes my hydrogen to 6, and I'm good. Alright, now what you need to do for me for homework is, if you'll get out that homework packet that we've been working through for this whole unit, on the front page, make that twin, please. On that front page, we had written the time, but we had not balanced it. So you need to balance the left-hand side. On the right-hand side, we had written the equations, but we had not balanced them. On the right-hand side, you will need to balance them. If you weren't super careful about checking these answers, which we went over in the class, right? So they should be good. So balance those. And then on the back, you'll need to do just the left-hand side. The right-hand side is crossed out. In your notes, I need to tell you 2 more things. But while you have your homework sheet out, on number 3, incomplete combustion is basically combustion that doesn't go all the way through. So on number 3, I'm going to give you the reaction. It's propane, which is CH3, and you'll have to balance it. Plus oxygen gives you carbon monoxide and water. So this is the reaction you'll be balancing. On the back, you'll need to write them out, make sure everything's neutral, and then balance them. And then you can skip number 10. So cross out number 10, write this on number 3, and there's one more thing I need you to put in your notes. So find your notes, write this down, number 3 on the back. I need to show you how to do combustion real quick. It's very straightforward. Skip 10. On the back of the front sheet. Alright, so last little bit of notes. Balancing combustion. So if you recall, combustion is nothing but a hydrocarbon, so they'll give you some kind of fuel, carbon and hydrogen. Sometimes it has an oxygen in the formula, sometimes not. But let's say we're combusting methane, which is CH4. So if they say balance the equation for the combustion of methane, you will take CH4, and then combustion is the same every time. What do I need to burn? Oxygen, and what is it going to make? Water and carbon dioxide. Y'all are so smart. So, the only thing about combustion is when you go to balance it, you have to write the elements in this order. You have to write out choke. If you do it any other way, you're going to be here all day. Alright? You just are. So anyway, so CHO. That's the only time it really matters. There are some other tips I'll give you about the order to write them in, but 1 and 4 and 2. And on this side, I have 2 oxygens, 1 carbon, and 1 carbon, 2 hydrogens, and 3 oxygens. See how I did that? It's not a problem, right? Okay, so let's get started. Carbon's good, hydrogen's not so much. I'm going to put a 2 there. That changes this to 4. And that changes this to 2 plus 2 is 4. And then I'll come over here. See how I need more oxygen? Put a 2 here. And that'll give me 4. It's really fast, but you have to write the elements in that order. And this one's a pretty easy one. Okay, so there's a couple tips. So, tip number 1. Single elements. So what do I mean by that? Look, do you see how oxygen is a single element? Put it at the bottom. Single elements go at the bottom. That'll make your life a lot easier. So single elements at the bottom of the list. And the other tip is elements that show up in 2 places. Oxygen also shows up in 2 places. It's in water and carbon dioxide in the product sign. Elements that appear in two compounds on the same side. Do you understand what I'm saying? Like what the oxygen was in water and carbon dioxide? Those also should go at the bottom. Oops. In two compounds on the same side go at the bottom. Some of y'all are really clever, and you'll also end up in AP Chemistry one day. So I'd like to show you a combustion trick, because that one was really easy. Combustion can be hard to balance. So if you're like ready to do your work and you don't want to see a trick, then you go do your work. But if you would like to see a trick, then you can listen to me. So some of the combustions can be like really hairy. So let's say that I have something like C4H10 plus oxygen gives me, if you're working on your own, that's fine, but be quiet. Okay, look, these are the same products every single time. So, look, the only place I have carbon on the product side is carbon dioxide. This carbon coefficient has to be the subscript for carbon. It's going to be. There's no other way to do it. So put the 4 right here. Okay? Now, this hydrogen subscript, guess what? It's going to get multiplied by 2 right here, but what should I put right here? That's right. So the water coefficient is half of that, because it's about to be multiplied by 2. Okay? And now all you got to do is take care of your oxygens. I got 8 plus 5 is 13. Now, what times 2 is 13? 6.5. You can't have partial coefficients. So at this point, you can multiply everything by 2. 2, 13, 8, and 10. If you were to make that list with CHO, you would be there for 10 minutes. That makes sense, right? Like it's so on that. I mean, if that's what you want to do, or you can make the list, but it would take you a long time, and you would be frustrated. Most of them, like on your practice, are not that bad. Okay. Anyway, so go ahead. And when you get started on that homework, it's classwork too. I mean, you guys are so lucky because we have until, 1:47, so you have over 30 minutes. The back ones are hard. The front ones are easy. So which ones do you want to do right here with somebody to help you? The back. So you do that back first, okay? The front is, you just bounce. The back, you have to write it out. You're probably going to screw something up. I'll give y'all a little bit of a head start, and then I'm going to put the answer key to the back up here. It's also on the blog under Unit 3 at the bottom.